Hi, so this is a Mandelbrot set. Back in 2001, I did a BSc degree at Staffordshire University in computer science. One of the modules I did was chaos and fractals, and in that module I built a Mandelbrot Explorer in C. I'm going to try and recreate that again now in Java and see how it looks on the higher resolution monitors and on a more modern PC, which should be faster. So the Mandelbrot set is named after Benoit Mandelbrot. He lived from 1924 to 2010. He's a Polish mathematician, and he first visualized the set in 1980. So what the Mandelbrot set is it's a simple function involving complex numbers. We'll have a look at what a complex number is in a minute, but what this does is it creates a sort of orbiting point, and if the point remains within a certain bounded area, then that number is in the Mandelbrot set. But if the point leaves the bounded area, that number is not in the Mandelbrot set. So we'll have a look at what that means in a minute. First, let's have a look at what a complex number is. A complex number is a number expressed in the form a plus bi, where a and b are real numbers, but I is the imaginary solution to the equation x squared equals minus 1. Now, no number squared can equal a negative number because a negative multiplied by a negative is a positive. So the imaginary part of the number cannot exist, but theoretically this is what a complex number is. Now we can plot complex numbers on a complex number plane. So we have the real axis and the imaginary axis. So if we have the complex number 3 plus 2i, we have 3 on the x-axis and 2 on the y-axis. So that's the real part of the number is 3 plus 2 lots of the imaginary part. Now this is the way the function behaves. So it creates orbits. So when we provide that function, if we provide it for some numbers, it goes into an orbit, and that orbit can shoot outside the bounds of the circle, which is our absolute number. Other orbits remain bounded within the circle. So if they remain bounded, they're in the Mandelbrot set. If they shoot off in a random direction, they're not in the Mandelbrot set. So let's have a look at a demonstration of that. So we've got a spreadsheet here. This table here is performing the calculations for the function by squaring the number and adding the complex number. And here we're plotting the result. So we've got the real part and the imaginary part. If I change these numbers slightly, so if I change the imaginary part from 0.6 to 0.61, we should see that the result changes. If I try 0.62, and that has gone off into the distance. So we can see that the number 0.273 by 0.61 is in the Mandelbrot set, because after so many iterations we remain close to the center. But if we change it to 0.62, then the value shoots off, so it's not in the Mandelbrot set. Okay, so I'm going to add a new project, and the first thing I'm going to do is just add a frame and a panel and get the window opening and closing. So let's do that. Okay, so it's very simple. We've just got Mandelbrot Explorer, which is a frame. That frame, we're going to set the size and set it visible. I'm also going to set the location so that we can see it on the second monitor here. I'm adding a listener to shut down the system if we close a window. And this frame contains a Mandelbrot panel, which has a paint method, which is just going to draw a line from the coordinates 1010 to 2020. Let's run that and see how it looks. Okay, that's exactly what I wanted. Little line there in the corner. So now I'm going to take straight in the C code and paste it in and see what parameters it takes, and then connect that up to the paint method, and hopefully we should quickly be able to see a Mandelbrot set. So let's try that. So I'm just going back into my actual assignment now, where it's all explained, and I should be able to get the code. I think it's in the appendix. There's the code. So let's take that and see how many errors we got, and then port it to Java. Okay, so I've called the method getPixel. So what parameters it takes real start and imaginary start, real end and imaginary end, and iterations. Now it looks like this is looping through X and Y for image height and image width, and this method here is actually doing the job for the entire image. I want to put this in a getPixel method. Actually, no, I'll do it the same way. So we also have a parameter for iterations. I think we can vary that, but we'll make a constant variable for now. I think I'll do 10 iterations. And we'll get this to do the whole job. So it's going to return void, and I'll call it draw Mandelbrot set. Now I think porting from C to Java is really going to be simple. So color F, I presume that that's a color. But here's image width and image height. So we'll pass it the panel and image width, which is an int, is going to be panel.width. Now here's a bit of dodgy programming I did in the past. I'm subtracting 22 from the height because I don't want to go over the status bar. Luckily I don't need to do anything like that now because the panel height is going to be the full height. So int image height is panel.getHeight. I don't think I'm going to need that. I'm not going to need that rectangle. This color ref, what does that end up being? That ends up being a color. I don't know why it's called B, but we'll keep it the same. So I changed iterations to be a static final int. It almost works already. So this is getting the color. We have red, green and blue mask. Now I had different color schemes available, but I'll get rid of this for now. This is so that we can have a red version or a green version, or if the mask values are all 1, then we'd end up with black and white shades of grey. So this is getting the red, the green and the blue value. All the values are the same, so I'll just say in grey scale is that, and then we want to say color color B equals new color grayscale of red, green and blue. And then we have set pixel. So here we've got if distance is greater than 2, so that's the bounding circle. So if the distance, this is measuring Pythagoras math.square root is measuring the distance of the point, the point of real and imaginary away from the center. If the distance has gone further than 2, then we are not in the Mandelbrot set, and we want to set the grayscale. And we say A equals iterations just to break out of that for loop. So break would be a better way of doing that. Else, if distance isn't 2, then B equals RGB 0. I think it would have been better to set B to be RGB 0 at the start for the loop for each pixel. In fact, what I'm going to do is set B to null. It's more efficient because I'm not building a new color object in each loop. So at the end, if B is null, then I'm going to take the static black value, B equals color.black. Somewhere along the line I've lost track of my brackets. Okay, so that seems everything's done. I just need to do this set pixel method. Draw. Pass the graphics object into this method. And g.draw pixel. Can I do that? Draw rectangle. XY 1, 1. I'm not sure if that's the most efficient way of drawing a pixel, but we'll see how fast it is. So I think that's it. Now I just need to call this method. -5, -5, 5, 5, this, G. So I'm going to plot the Mandelbrot set from -5 to 5, 5. Now I've got no idea if this is going to work, so let's have a go. No, nothing. We seem to have black. Complete black. Okay. Okay, we are getting some different values out of grayscale now. Oh, I think I've run out of console lines, but I'm not doing g.setColor. I think I did have a problem with things rounding over here because I was getting the casting wrong, but I definitely need to be setting the color of our pixel. Now I think the function takes a few seconds to run, but I'm expecting to see right there we have a Mandelbrot set. Now the sort of jagged edges I think are because I'm not doing enough iterations. If I do more iterations it's going to slow things down, but I think I'm going to actually reduce the number of iterations for now and get the function of moving things around so that we can pan and zoom. I'm going to do that from mouse events so that we can drag the image and use the mouse wheel to zoom in. I also don't know why I'm not going to the edge. That'll be a rounding problem again, but I'll do this first. I'd like to get the image to appear quickly, so I'm going to see what happens if I just do 2 iterations. So while I'm testing the function to pan and zoom, I can at least get an image appearing quite quickly. Right, that will do for the testing actually. Okay. I'm going to see how quickly it would draw a resolution of 100 times 100. And the reason for this is because I'm thinking that when we're panning and zooming we could set the resolution really low so that we could see the image moving, and then when we let go we could then go on to a full render. So let's just see how quickly that draws. Go back to 10 iterations. That's pretty quick. So I'm going to draw the full screen but with a resolution of 100 times 100, so it's blocky. Okay, so now I'm doing the whole thing with just a reduced resolution, just so we get things moving quicker. And then the plan is I'm going to make it pan and zoom, and then when we let go of the mouse I'll make it render a more detailed image. That's rendering really quickly there. I've also got to sort out a bit of the image size isn't quite right. Okay, so there's our image rendering quite quickly. And if I set the image width and height to be the width and height of the panel, I should get a high quality image. Right. And if I put iterations up to some high value, it should take some time, but I should end up with a very nice image. There you can see the detail in there. Okay, so I'm going to get the panning and zooming working, and then we'll have a look at the I'll do it in the reduced quality so it's fast, and then I'll increase the quality when we let go of the mouse. Another thing is it seems to be pointed down. The heart shaped thing is pointing down where usually it's pointing to the right. So let's see if I got my X and Y mixed up. That should be pretty simple. I could just swap X and Y over. Yeah, I need to think about that a bit more actually. I'll swap X and Y over in the function rather than the meaning of the pixel. Right, that's right. Okay, so I've just implemented the pan function in a mouse motion listener in the mouse dragged. So I'm working out how far the mouse was dragged by every time the mouse is moved or dragged. I'm saving the last mouse position in X and Y coordinates, and then when it's moved I'm working out the difference between the real end and real start. So that's the width of the image in the real number plane, dividing that by the number of pixels. So I've got the real number plane width per pixel, and I'm multiplying that by the how far the mouse moved, and I'm adding that onto the real start and real end. That real start, real end, imaginary start and imaginary end, I was passing that to the function, but now I've put that as a variable outside. Doing exactly the same for Y, but in the imaginary plane, and using the height instead of the width. And I'm not repainting yet. I will need to call a repaint. So after that has changed, I just need to call repaint. And now we should have a drag function, but still a low quality image. Yep, that's exactly what I wanted to see. So next I'm going to implement the zoom function using the mouse wheel, and the idea is going to be is that we could drag the image around like that, zoom in and out with the mouse wheel, and then when we let go we'll render a high quality image. So let's do the zoom function now. Okay, so I'm working out the size of the real plane by getting the end of it, subtracting the start of it. I'm getting the center point by getting the start and end over 2. Then I'm working out zoom. I'm not sure if I've done this right, but I'm doing 1 minus the value that we got out of the mouse wheel. And then the size, I'm multiplying the size by zoom, which should, maybe that's going to be way too big, but we'll see. And then I'm recalculating the start as a center minus the size over 2, and I'll recalculate the end as a center plus the size over 2. I'll see how this looks, and then I'll do the whole thing for the imaginary as well. So let's see how this looks. Okay, oh, I forgot to repaint, and also it was way too far. I think I can just reduce this value. Sometimes experimentation is the best way to do things. After doing this, I'm going to need a repaint. If it's completely wrong, right? Oh, it went off to the side. So did I get the center right? So I'm going to debug through this and see what happens. So we're starting off with -5 to +5. We're stuck somewhere else. Are we stuck there? Just start again with the debug. So I'm just going to try and zoom in one click, and let's see. So units to scroll is -3. So size, our end is 5 and our start is -5, so the width should be 10. The center point should be 0. 5 plus -5/2 is 0. Zoom is giving us a value, a very low negative value. Size equals size times 1 plus zoom. It should have been, because yeah. Otherwise I'm saying rescale the image to the amount that we want it to change. I think that should be right now. No, it's not right. Let's have another look. Our size 10. It should be our size equals our size, not multiplies. It's still not right. Okay, so that's right, because we did have an R size of 10 and now we've got 9.96, so that's roughly right. R start equals R center, and R start, I need that to be R end. So there was a lot wrong with that, and that just shows the value of debugging, because I would have been staring at that for ages trying to work it out. I'm confident it's right now. Yeah, it's very gradual, but they're zooming in on the X and zooming out on the X. I think I'll make it a bit more sensitive. That will be the zoom sensitivity, so I'll make that a variable. And I think I'll make it quite a bit more, 10 times, as that seems to be, that feels, it still feels a bit slow to me, but I'll make it more. In fact, make it 1, maybe 1 is, maybe 0.5. And I'll now do the imaginary axis as well. Okay, so now we should be zooming in and out. So that looks quite good. Now there's two ways to improve it now. We can improve the iterations and we can improve the resolution. So when we've let go of the mouse, and also when we're not scrolling in and out, we want to draw a high quality image. This may take some experimenting. Let's see if we put the iterations up to 25. That's still fast. So it's really the pixel number we care about. If I put the iterations up to 250. I'm just going to see what it's like in sort of full quality. I think it's going to be really slow. It's not bad, it's not bad. It's way faster than it was in 2001, even written in C. But I don't have enough iterations because the detail, but we can see the interesting patterns, but we do want more iterations because we're starting to see sort of curved edges. But I think we might not have to do anything particularly clever with the resolution if this works. Okay, so now we've got quite a high quality image. If we go to 255 iterations, then we've got as many iterations as colors and the grayscale. So 250 is quite high quality. It's looking quite good, and if we zoom in we can see some really nice patterns, and we can see that shape, kind of different distortions of that shape coming up again. And if we go in, of course we can infinitely go in forever, and we see the same sort of patterns reappearing. So that's the Mandelbrot set. There's a couple of changes I'd like to make. I'd like to make it that when we zoom, it's the mouse pointer that stays in the same place rather than the center of the image. So in that way I could point to a bit that I like, zoom the scroll wheel, and we'll go in there. So I'll make that change now, and then we'll have a look at a few other tweaks. Okay, so I think the easiest way I can do this is by just offsetting the image so that the center point before we do the zoom is where we're pointing our mouse, and then putting it back again when we've finished with the zoom. I'm not sure if I've done that right. So I'm getting the real offset should be the width of the real image divided by the width in pixels multiplied by the last mouse X position. Let's see if it works. No, it doesn't seem to work at all. We still zoom into the center. Okay, so to fix it, I'm just going to look at the X thing. Maybe I should be adding at the start and multiplying at the end. Sometimes it's quicker just to try than to think too much about it. So I'm going to point at that circle there. No. Okay, so I think the calculation I was doing for converting the point on the screen to the real value was correct. So I'm going to do that calculation before I do the zoom. I'm going to do it again after I do the zoom, and I'm going to add the difference to the two R values. So I'm just trying to get it right for the X now. Now I'm probably doing it the wrong way around. So just subtract it. So if I point over to the box on the left and zoom, the box on the left, the bit of it that we're pointing at, the X value stays where it is. Well, I'll do the same for the I that I just did for the R. Okay, so now we should be able to point wherever we want in the image and do the scroll wheel, and that part of the image should stay where it is. So if I point over to this blob on the left and zoom, we zoom in on the blob on the left. I think I've gone way too far there. Zoom out. Yeah, I think this is the whole blob on the left, and this is, oh no, yeah. So we go over there. We can just point and slowly zoom, and we're going wherever we want to go. Now I'm going to do the thing where I do it in a reduced resolution first, but I'm not going to quite go down to the 100 by 100 level. I'm just going to try maybe, let's see what 300 by 300 looks like. And then I'm going to do something to draw the image at this resolution and then draw it at another resolution. But if we we can somehow interrupt the paint method. You see that's really fast. We can zoom in and out of here really quickly. So what I want to do is, if we stop zooming, we then draw a high quality image and maybe repaint between every line. No, I'll do a bit of experimenting and see what I come up with. Okay, so I've been experimenting around with a few different things, but what I think I'll stick to is I've got a high quality flag, which is true or false, a boolean, and then when we draw our fractal, we say if high quality, then make the resolution of the screen the full resolution of the screen. If not, make it some reduced level, let's say 100 by 100. And then when we are panning or zooming, we're going to call a new thread, and what that's going to do is it's going to set high quality to false, and it's going to draw the set with high quality false, then it will set it to true and draw it again. Now there's also an interrupt flag, and that gets set at the beginning of this method, and if the interrupt flag is set whilst we're drawing the whilst we're drawing the high quality image, we'll abort out of the loop. We're drawing this image to a buffered image, and then when we finish drawing the image, we'll call repaint. Repaint will draw the image to the panel. So really what I'm doing is I'm drawing two images, a reduced quality one, and then I'm immediately getting on to drawing a increased quality one. So that, I think, is that's the effect I wanted. So we can see roughly where we are. We can see that there's one of those shapes in there. We can go up against the edge and wait for it to load, but we can navigate around without worrying about so we can move quickly around without having to wait for the whole image to reload. So that's roughly what I wanted to do. I might have one last play around with the colors, see if I can make it look a bit more interesting. Okay, I'll have a go doing something with the color. Not really sure what to do, so I'll just do the green component of the red, green and blue as the opposite of the red and green. Right, so that just adds a bit of colour to it. And that is our Mandelbrot set. So I'll make this program available on my website. I'll also make the source code available so you can download it and have a play with it yourself. Maybe you can improve it, maybe give it a different color scheme, or maybe try a different number of iterations of the loop for the set. So that's it for now. If you've learned something from the video, give it a like. And if you'd like more videos like this, then subscribe to my channel and hit the notification bell so you get notified when I make new videos. And thanks for watching.